Welcome, dear students. In these days, I'm dealing with the most important topic of genetics and plant breeding, that is heterosis and inbreeding depression. I've already dealt the definition of heterosis and history of heterosis and inbreeding depression, you can say. Now I'm going to deal the inbreeding depression. See, the reduction or loss in vigor and fertility, as a result of inbreeding or selfing. Means whatever reduction is coming in next generation because of selfing or inbreeding, that reduction is known as inbreeding depression. If you measure the inbreeding depression, you can say that inbreeding depression percentage, that is F1 bar minus F2 bar divided by F1 bar multiplied by 100. So if you see where F1 is average performance of F1, F2 bar is average performance of F2, and if you put the example, if F1 hybrid is giving the 70 quintals per hectare, and you have shaped the seed of that and you have again grown it, the F2 generation, and you have seen the average yield performance of F2 generation of the same hybrid. So if it is giving 60 quintals per hectare, so go for inbreeding depression percentage, 70 minus 60 by 70 multiplied by 100. If you multiply, you will be finding this 14.29% yield reduction in F2 generation itself. So this formula for measuring the inbreeding depression is for any crop, whether it is cross-pollinated or self-pollinated or often cross-pollinated. But this has been given when you are using the hybrids, the F1 generation, when you are calculating over the F1 generation, then sure you are going to get inbreeding depression. Whether inbreeding depression you are getting, whether it is self-pollinated, cross-pollinated, often cross-pollinated, you are getting the inbreeding depression. The extent may differ in this. But this measurement is for the F1 hybrids only. I will be dealing the natural population, inbreeding depression in natural population later on, and I will be dealing the extent of degree of inbreeding depression. So this you see the inbreeding depression in case of hybrids, calculating over the hybrids. Effect of inbreeding causing the inbreeding depression. It is a reverse of heterosis. You see, if you are getting the hybrids, you are getting the heterozygosity at a large number of loci, and because of that you are getting heterotic performance. But if you are going for inbreeding or selfing, you are enhancing the homozygosity in the population. So of course, what is the effect? Appearance of lethal and sublethal alleles. You see, wherever, if you are selfing or inbreeding, wherever capital A, small a is there, at maximum places you will be finding small a, small a. So the small a, if you presume that recessive alleles are deleterious, then what will happen? They are open to express if they are coming in homozygous condition. So because of inbreeding, appearance of lethal and sublethal alleles is there. Reduction in vigor, of course, vigor will be reduced. Reduction in fertility, of course, there will be. Reduction in yield and other traits, yes, it will be there. Increase in homozygosity, of course, the homozygosity will be increased. In hybrids, I'm talking about the hybrids, whether it is self-pollinated, cross-pollinated, or any crops. But in naturally occurring crops, I'll be dealing later. Cause of inbreeding depression, I have already discussed that increase in homozygosity lead to appearance of recessive alleles, which are deleterious to plants. So this can can be seen easily. Now you come to the degree of inbreeding depression. If you talk about degree of inbreeding depression, you can see how you get different degree of inbreeding depression in different crops. It is all depending upon the nature of the crop. There are some crops which are highly cross-pollinated. There are some crops which are moderately cross-pollinated. There are some crops which are often cross-pollinated. There are some crops which are self-pollinated. So one by one we will be discussing. So the higher and higher cross-pollination, higher and higher heterozygous alleles, loci you are getting. At large number of loci, you will be getting heterozygosity. If it is highly cross-pollinated, if it is cross-pollinated, moderately cross-pollinated, of course you are having heterozygosity at many loci, but not up to that extent. So depending upon these nature of the crops, you are getting inbreeding depression. Higher and higher cross-pollination, higher and higher heterozygosity. I'll be dealing with the hypothetical example. So higher and higher heterozygosity, higher and higher inbreeding depression in naturally occurring crops. Don't confuse it with the F1 hybrids. F1 hybrids will be getting inbreeding depression, whether it is self-pollinated, cross-pollinated, anything. But in naturally occurring crops, say for example in self-pollinated crops, if it is not hybrid, natural variety, maybe inbreds, maybe pure lines. Inbreds and pure lines, they are homozygous in nature. If you self them, they will not show any inbreeding depression. But at the same time, if you are having hybrids of rice, the self-pollinated crops, it will show inbreeding depression. So I have discussed here the inbreeding depression in F1 hybrids. Now I'm dealing here the degree of inbreeding depression in different crops. So you see that the extent of reduction in performance in inbreds, pure lines, OPB you find in cross-pollinated crops. These you find in self-pollinated crops. Inbreds, here I'm talking inbred varieties, not inbred line. Inbred lines are available in cross-pollinated crops. Of course, the inbreds are available in self-pollinated crops. So OPB, open pollinated varieties, synthetics, composites. OPB, synthetics, composites you are finding in cross-pollinated crops. So the extent of reduction in performance in inbreds, pure lines, OPB, synthetics, composites due to selfing or inbreeding, that is called degree of inbreeding depression. So how much extent you are getting in different crops in natural condition? If you are selfing, the naturally occurring crops, highly cross-pollinated crops show high inbreeding depression, whereas self-pollinated crops do not show inbreeding depression. If you self the pure lines, if you self the inbreds, there will not be any reduction from that variety. Now come to the hypothetical example. If you see here, now you see here, thousands and thousands genes are there in the crop, 30,000, 40,000, 50,000 in different crops. So I cannot put the example of all the genes. So I'm putting few, 4, 5, 6 genes, and I'm trying to explain the degree of inbreeding depression in different crops. Say for example, this is the example of self-pollinated crop, which will be highly homozygous. You see, at all the loci you are getting homozygosity at all the loci. Of course, this variety is different, this variety is different. This is capital A, small b, small c, capital D, capital E, capital E, small f. How it is different? Because this is all homozygous. Now you see small e, small b, homozygous. Capital C, homozygous. Small d, homozygous. Small e, homozygous. Capital F. If it is like that, see the difference. Both are self-pollinated crop. Both are homozygous, highly homozygous. So this is one. If you self it, what you will be getting? Same capital A, small b, small c, capital D, capital E, small f, small. Same you will be getting. So there will not be any reduction in the performance. If it is pure line or inbred variety, you will not get any reduction while selfing. Of course, if you have hybrid, F1 hybrid of this also, self-pollinated crops also, you will be getting inbreeding depression as per the formula. So this is there. Now you see there are different crops having different extent of heterozygosity in it. I will be dealing with them with hypothetical example. You see here capital A, small b, capital C, capital D, small d, capital E, small e, capital F, small f. You see in this variety you are having at two places, and you count the percentage 1, 2, 3, 4, 5, 6. I'm dealing with the 6 genes, and out of 6 genes, here you are finding at 2 loci, at 2 genes, this variety is differing, having heterozygosity, and at all other places it is having homozygous. So you count the percent of heterozygosity available, heterozygous alleles available in this crop. Now you see this crop, capital A, capital B, small b, capital C, capital D, small e, capital F, small f. Now you count 1, 2, 3, 4, 5, 6 genes example. 1, 2, 3, 4. At 4 out of 6, 4 loci is having heterozygosity. So you see, count the percentage of heterozygosity in that variety or that crop. So of course this is having higher heterozygosity, means this is more cross pollination is occurring in this as compared to this. So this will be showing more inbreeding depression as compared to this. This is going to show you little inbreeding depression. This is showing more than this inbreeding depression. And now you see another crop is having capital A, small a, capital B, small b, capital C, capital D, small d, capital E, capital F, small f. 1, 2, 3, 4, 5. Out of 6, 5 loci is having heterozygosity, highly heterozygous in nature. So highly inbreeding depression you will be finding here. So now you see in natural condition, this was the hypothetical example to explain you better in a better manner. Now you see different crops, the practical real situation in different crops. First, high inbreeding depression. Where you find high inbreeding depression? Several plant species like alfalfa, carrot, etc. show very high inbreeding depression. In these, large proportion of plants produced by selfing or inbreeding show lethal characters and do not survive even. If you are going for selfing, you are taking the seeds, large number of proportion of plants in the next generation is not surviving even. See the lethality. The problem of the lethal genes which were suppressed because of the heterozygosity and because of the homozygosity, plants even not surviving. Maximum plants are not surviving. And the progeny which is surviving even, and if you are calculating its performance, so it is less than 25% if you count the yield, if you calculate the yield. If you see the yield performance of these inbreds of these, if you compare it with the open pollinated variety from where it has been derived, you will be finding that the inbreds of these crops are not getting more than 25, even 25, less than 25% yield potential. The plants which are surviving, maximum plants are dying. So this is the case of high inbreeding depression. Now I will be dealing the next. So you have seen the high inbreeding depression in highly cross-pollinated crops like alfalfa, carrot. So if you go to hypothetical example, you can put this example as high inbreeding depression. This will be showing high inbreeding depression where the proportion of heterozygosity is high. Now you come to moderate inbreeding depression. If you talk about moderate inbreeding depression, you can see many crops or many crop species such as maize, sorghum, pearl millet, etc. show moderate inbreeding depression. Though many lethal and sublethal types appear in progeny while selfing, but substantial proportion of progenies can be maintained under self-pollination. Because of that, you are able to produce the inbred lines. Inbred lines in maize or jowar or bajra, pearl millet, whatever, sorghum. So a large number of inbred lines can be maintained. But if you compare the yield performance of even better inbred lines, so from single open pollinated variety, when you are going selfing, you can produce large number of inbred lines from a single OPV. So if you compare those inbred lines whichever you have developed, so the best inbred line is showing maximum 50% yield performance as compared to the open pollinated variety from where it has been developed. So this is the real picture, the moderate inbreeding depression. And if you come to the hypothetical example, you can find that this, you can see the percentage of heterozygosity. This may be kept as a crop where moderate inbreeding depression you are finding. Now come to low inbreeding depression. There are many crops where extent of cross pollination is lower than the maize and sorghum and pearl millet. Several crop plants, for example, onion, cooker beets, sunflower, etc., show only a small degree of inbreeding depression. Only a small proportion of plants produced by selfing or inbreeding show lethal or sublethal characters. The reduction in yield is small or sometimes absent And some inbreds produced by these crops may yield as much as their open pollinated varieties from where they have been developed. So if you see the hypothetical example, you can see this one. The proportion of heterozygosity is lower as compared to this and this here in third one. So this is the case of low inbreeding depression. Now if you talk lack of inbreeding depression, I have already discussed several times today. All self-pollinated crops do not show inbreeding depression. However, they show considerable amount of heterosis. But inbreeding depression, whether it is cross-pollinated or high cross-pollinated or self-pollinated, if you have developed hybrids in that, there will be inbreeding depression from the F1 hybrids. But in natural condition, in self-pollinated crops, there will not be any inbreeding depression. What will be the hypothetical example of those crops which are self-pollinated? The situation homozygosity, heterozygosity, you see, complete homozygosity, you see. These two types of the crops are showing lack of inbreeding depression. So, dear students, now I have completed the inbreeding depression. I will be coming in next with the more and more topics related to heterosis and inbreeding depression mechanism. Thanking you very much.